Today we're going to talk about chemical reactions. We're going to talk about the reactants, so the things that start in a chemical reaction, the products, the things that we end up with at the end of a chemical reaction, and activation energy, the amount of energy needed for the chemical reaction to occur. So as we take a look at this, you'll notice I've started right here with a couple of chemical equations. I have three, one up here, one in the middle, and one down below. I have underlined all of my reactants in black and all of the products in orange. You'll notice that all of the reactants are actually before the arrow. Okay? So to identify a reactant, what you're going to do is you're going to look at, if you have a chemical equation written out, what's written before the arrow. The products are what we end up with. If you think about it in a store, you go to the store, you buy products, things that have been made. And so that's what we have at the end here. You will notice that my last two equations are actually opposite from each other. Some chemical equations and chemical reactions can happen in one direction and in the other direction. Okay? With that, what happens is the carbon dioxide here and the water actually join together to form H2CO3. Now, this happens in our blood. When our oxygen's been used, we have our carbon dioxide. It mixes with the water within our bloodstream, and then it forms this H2CO3, which gets carried to our lungs. As it gets carried to our lungs, once it gets carried to our lungs, the water stays within our bloodstream, but the CO2 breaks apart from it, okay? And we now have two products from our H2CO3, and we have CO2, which goes into our lungs and then gets released from our body. So products are what we start with. Reactants are what we start with. Reactants are what we start with. Products are what we end with. Now, lastly, we're going to take a look at a couple of graphs here. Chemical reactions need energy to occur. Our reactants have a certain level of energy, and then our products have a certain level of energy. And the chemical energy that's used to go through it can either be released. A lot of times if you have a chemical reaction happening and you feel heat, energy is actually being released from that chemical equation. But the other thing that we need is an activation energy. Activation energy is the energy needed that needs to be added to something before the reaction can actually occur. So we have our reactants here, which have a certain level of energy in them. Our activation energy is the energy that needs to be added to reach the top of this hump. Once we reach that amount of energy, then our chemical reaction can occur, and we can then form our products. Same thing here, although this activation energy is much lower than the top one. Okay? Now, the other piece is how much energy do the reactants have and the products have. So here our reactants have less energy than our products. So our chemical reaction is going to actually absorb energy. Whereas here our reactants have higher energy than our products do, so this is going to release energy. And sometimes you may have heard of chemical reactions happening spontaneously, something just randomly happening, and that would be a spontaneous reaction with a release of energy. Any chemical reaction that releases energy can actually happen spontaneously if our reactants have enough energy in them. So, our activation energy is the amount of energy it takes to be added to the reactants to be able for it to occur. And then some chemical equations can release energy and some will absorb energy. So we've talked reactants, what we start with. We've talked products, what we end with. Activation energy is the amount of energy needed for the reaction to happen. And then you can also identify if a reaction absorbs or releases energy.